So the next panel is a panel on perspectives from climate science. As I said before, the chair is an expert in legal aspects and law, and the three speakers are three scientists who have really contributed a lot to what we know about climate change. So I will introduce the chair of this workshop, of this panel, and then I will leave the chair to introduce the three speakers. Christina, I will then help you after the three speeches to manage the Q&A session. So I will try to manage with you the Q&A after the talk. Great. So let me introduce Professor Christina Voigt, who is from University of Oslo, Norway, and who is a member of a steering committee of a International Union for Conservation and Nature. Christina had her legal education at the University of Passau in Germany, and then did a master in environmental law at the University of Auckland, New Zealand, and a PhD from the University of Oslo, Norway. She's very renowned expert in international law and professor at the University of Oslo. She has published widely on legal issues linked to climate change, environmental multilateralism, sustainability, and is a frequent speaker at national and international level. She has worked for more than 10 years as a legal advisor to the government of Norway, and she has been a lead negotiator for Norway on the Paris, involving the Paris Agreement. She is co-chair of a Paris Agreement Implementation and Compliance Committee and chair of a climate change specialist group of IUCN. So it's my great pleasure to have you here, Christine. Thank you very much for agreeing to chair this panel. The floor is yours. I will be in the background and I will appear again when we move to the Q&A. So you manage the three speakers, their timing and so on. Thank you, Christina. The floor is yours.
Thank you so much, Roberto. Thank you for this kind introduction. It is a pleasure for me to be here, and it's a pleasure for me to chair this particular panel. As you said, I've worked for a long time on climate change related legal issues, and of course in the context of climate litigation, as we've been talking about in several sessions today. The issue of climate science comes or meets climate law very directly, and that's a very interesting but also very challenging combination. And we see many cases now coming forward where the judges, where the courts are referring to climate science, but in very different ways. Like each court does it in its own manner and in its own capacity. And we see references, of course, to the IPCC reports, especially to the assessment reports, but also to the latest special reports, particularly the one on 1.5 degree warming. That seems to be the common starting point, but we also have cases where courts or the judges are referring to domestic research institutions, to peer-reviewed articles, to scientists that they call into hearings. So we have a wide spectrum of different ways to include science in litigation and in, of course, the legal findings then put forward by courts. And for that reason, it is a particularly interesting setting to have three scientists with us who can discuss with us and hopefully with the audience and lawyers in the audience there then of what are their perspectives on climate science, and maybe also how and in what way should and could they come into legal proceedings. It is therefore my privilege to introduce the first speaker this afternoon. This is Filippo Giorgi. He is the director of the Earth System Physics section at the International Center for Theoretical Physics in Trieste in Italy. And Filippo is going to talk about climate science and where do we stand today. Filippo, you have the floor.
Okay, thank you very much, Christine. Let me share the screen. Okay, can you all see? Okay, in here?
Yes, we can see and hear.
Okay. As Christine said, I'm a climate scientist. So I stand on the sort of physics well, everything is a science. So the physics side of the climate change issue. Roberto asked me to sort of provide a overall update on where we stand. Of course, in 15 minutes is not easy. So we'll give you some of the facts that science today knows, and then pose some questions, especially for the other side of the panels, the law side. I should also mention that what I will be talking about is based on the last IPCC report, the 2013 one. As you well know, in less than a month or about a month, the new report will come out. I actually don't think the conclusions will be incredibly different from what we already know. But maybe some of the figures will need some updating. First, as I said, some of the facts that our science knows. The first one is global warming is happening. This is a conclusion that I don't think is disputed anymore within any type of scientific community. The global temperatures have increased by slightly more than 1 degree since the beginning of the 20th century. I don't know what the official number will be in the next report, but probably a bit more than one degree. There are oscillations due to climate variability that often have been misinterpreted with, climate change has stopped or whatever. But I think everybody today agrees that we are in a phase of global warming. So this is a certainty within the scientific community. Another almost certainty is that most of this global warming is due to actual human activities, in particular to the emission of greenhouse gases, mostly carbon dioxide from use of fossil fuels. You see here the famous Keeling curve showing the increase in carbon dioxide. We went from about 280 parts per million pre-industrial values to, I think the latest numbers are 415 or something, or 413 or something like this. That's an increase of more than 40% in 100 years, 120 years, which is a huge increase that our climate system has not seen, at least in the last 3 million years, at least the speed of this increase. But we also today know that this, what is called the attribution, is also not disputed very much. That in the last report was a 90% attribution probability that most of the warming, at least since the mid of the 20th century, is due to anthropogenic increases in greenhouse gases. The other big greenhouse gas is methane, which has more than doubled in the last 100 years. And this is mostly due to intensive farming. This number 95% has increased during the last reports. It was, I think, 66, maybe Myles can correct me, but I think it was about 66% in the third. Then it went to 90 in the fourth or whatever, and then 95 in the fifth or something like this. I would be very surprised if we had a smaller probability in the next report. So these are two facts. Global climate is warming. Greenhouse gas, three facts. Greenhouse gases are increasing due to human activities, and the greenhouse gases are mostly the biggest contributor to the observed warming. Another fact is that this global warming is actually changing in a profound way, in many different ways, many aspects of the climate system, aspects that affect ecosystems, natural ecosystems, and different sectors of society. We know that there are modifications to the global circulation patterns. For example, we know that there is an expansion ongoing of the Hadley cell, so pushing towards the poles the direction of storms. So this causes an increase in precipitation over the high latitudes and a decrease in the tropics and tropical regions. We also know that glaciers are melting. Glaciers are our biggest water reservoirs. So glacier melting is not only an ecosystem issue, it's really a survival issue in terms of water availability. We had a study like a few months ago where we showed that most of the alpine glaciers, up to 90% of the alpine glaciers, might actually disappear by the end of the century. And all of the alpine glaciers are actually in a phase of recession. We know that the hydrologic cycle is being affected by global warming. This effect is most often called an intensification of the hydrologic cycle. So we have more intense rain events and more and longer dry periods. This has been observed in many parts of the world, and this increases the risk of, on the one side, flood events, and on the other side, drought events. And what you see in this figure in the bottom left is the number of catastrophic events of meteoclimatic nature, like droughts, floods, and so on, fires, and so on. These are data from the Munich Reinsurance Company that show you that since 1980, the number of these events has increased by a factor of 4. We went from about 200 globally to about 800. That's a doubling time of 20 years, which is a huge, really huge doubling time. And I think Myles will talk about the attribution of these extreme events to global warming. And then we also know that sea level is increasing. I don't know what will be the official number in the next report, but in past reports was about 20 centimeters in the last 100 years. And what you can see from this curve to the bottom right is that actually global sea level rise is accelerating in the last decades. So all these things are going to are affecting already, again, different ecosystems and different sectors, socioeconomic sectors. And this, they're affecting in an adverse way, of course. Things are not, of course, they're not being made easier for us by all these changes. I already talked about glacier melting, reducing the availability of water. Of course, increasing extreme events increases the damage associated with these events and so on. This figure, again, from the last report, 2014, simply shows that essentially the impacts of climate change on different socioeconomic sectors are now evident everywhere. Probably there will be an update of this figure where you will see many, many more of these, maybe, I don't know, but it would be nice to see whether there are many, many more little symbols, meaning that these impacts will be more and more. So these are all facts. I don't think there is much more of a big dispute on these results in the scientific community. So this is what has happened so far. And of course, our models also tell us what might happen in the future. As you know, there are different scenarios, and I would like to draw your attention on this figure. This figure you see here shows the global temperatures reconstructed in the last 11,400 years, a period that we call the Holocene. It's a period where it's the last, as you know, the last 3 million years have seen this alternation of glacial periods and interglacial periods. The last glacial maximum was about 20,000 years ago. These are due to some, the so-called Milankovitch cycles, some small modifications, regular modifications of some characteristics of the Earth's orbit. About 10,000 years ago, we reached the optimum, of the interglacial time. The climate has been relatively stable for about 5,000 years. Incidentally, this is the period where civilization really blossomed, we could say, because people didn't have to follow climatic niches. And then about 4,000 to 5,000 years ago, we started this slow descent towards the next ice age, which will be reached maybe in another 20,000 to 30,000 years. So not something that we need to worry about now. But this is what's happening now. This is the 1 degree global warming. In fact, this is paper from 2013, so it would be even higher. So you see that what worries is not so much the temperatures that we have today, which might very well be the highest in the last 10,000 years, but it's the speed at which this is actually happening. What you also see here is where the global temperatures might go in 2 scenarios. One is the Paris Agreement scenario. These are 2 degrees global warming say, the target of the Paris Agreement, 2 degrees global warming compared to pre-industrial temperatures, but 1 degree is already gone, so it's another degree compared to today. So the curve would go all the way up here. This is all in scale in another, say, 80 years. And this is what many call the business as usual scenario, the RCP 8.5. Somebody doesn't like to call it business as usual, but if we sort of continue to burn greenhouse gases, burn fossil fuels as we are doing now. So you see that even in the case of the Paris Agreement, the Earth's climate would see a perturbation that it has never seen, I think, in the last 3 million years during warm periods. It's something never seen before. And of course, if we go even higher, now we could go to, we could argue whether it's going to be 4 degrees, 3 degrees, or whatever. Before, I think somebody mentioned 3 degrees. It doesn't matter. The thing that matters is if we go on this way, we're going to give to the Earth a perturbation that has not seen in the last at least 1 million years, probably in the last 3 million years. And with global warming, all these effects, these sort of collateral climatic effects that I talked about, glacier melting, sea level rise, whatever, will become stronger and stronger, and really have the potential to threaten the sustainable development of society, at least as we know it. And in fact, there was a paper on Nature, I think, or Science, I don't remember, a few years ago. They showed that if we go with the business as usual scenario, we might affect climate for the next 10,000 years, which is really something pretty amazing. So we can really say that we have entered the Anthropocene. Of course, if we enter the Anthropocene and human activities can modify climate, we have also a big responsibility. Now, let me see if I can go to the next slide. There are some specificities to the climate change issue that I think are very relevant for, let's say, legal implications. First is a spatial sensitivity. And this one is that climate change is not homogeneous throughout the planet. There are some areas that we call the climate change hotspots that are much more sensitive to climate change than other areas. Here I've identified a few. The Arctic, of course, because of the ice melting, is the main hotspot. You know that the Arctic is warming at a speed that is more than double the rest of the globe. But there are some other hotspots. One is in fact the Mediterranean, that our models are telling us will be much hotter and drier than today, but then the Amazon basin, Southern Africa, and so on and so forth. So climate is really a cross-boundary issue, and the main point I wanted to raise is that the primary contributors to the climate change problem are really not also the primary victims of climate change. In fact, it's quite the opposite. So I think this can have quite some important types of legal implications. The other specificity is a temporal specificity. The Earth's climate has a fairly strong inertia because of the oceans, but also because the lifetime of greenhouse gases is very long. The lifetime of CO2 can be decades, even centuries. The lifetime of methane is about 12 years, but CO2 is very long, and you see here the lifetimes of halocarbons and other greenhouse gases. This means that what we do today really will affect climate for many, many years, for several generations. So climate change is really a cross-generational issue, I sort of state in this slide, in the sense that our actions are really going to affect several future generations that are really innocent generations. I mean, they're not contributing to this problem. These are our children and our grandchildren. Some generations have not been born anymore, but they will see the deleterious consequences of what we do or we don't do today. So I think this, my opinion, of course, this may sound a bit naive, but I think this is really a very important issue about litigations concerning climate change. Another point is that that I wanted to raise is that today our science also tells us that we know how to stop, or not to stop global warming, but to keep it within manageable boundaries, manageable limits. These 2 degrees global warming identified in the Paris Agreement is sort of what we consider a danger threshold. I mean, below this threshold, we can actually kind of cope with the impacts of climate change in a sustainable way. Beyond this threshold, and this is not a number that just came out of the blue, this number was discussed based on many scientific studies. Beyond this threshold, then the impacts of climate change become unsustainable. But we know that we can stay within this threshold, so avoid the danger level, through a portfolio of what are called mitigation options, so reduction of greenhouse gases. I cannot go through all of them. For example, the decarbonization of the energy system. All this is being sort of put together into the term of green economy. We know that a transition to a green economy will sort of save us from a big climate emergency. And we also know that this can be done at sustainable costs. What you see in the IPCC Working Group 3 report is an estimate of the costs of mitigation to stay below the 2-degree global warming levels. And this goes from 0.04 to 0.14 of the global GDP, gross domestic product, which is really, if you ask me, I mean, I don't know, maybe there are some economists, there might be a few zeros here, but in terms of real value is really not that much, given that every year the global GDP grows by 3 or 4%. So we know that what the problem is, we know who is causing it, and we also know how to solve it. So I think, having said this, there are some questions that I like to pose to this panel or to whoever. And since climate change, as has been said, really affects some of the basic rights of people. The right to have a home, to have a safe home, to have sufficient food and water, to have health. Some people even say that this COVID-19 pandemic might be related to environmental issues, to have education, safety, and so on. This has been affected by climate change. And so the questions I would like to pose are the primary contributors to global warming ethically and legally liable towards the victims, since there's not much superposition between the two? And when I say the contributors, I mean all of us. I mean we all in some ways contribute to global warming, more or less, when we drive our cars, if they're not electric cars, or when we heat up our houses and so on. And how do we really deal with this type of liability? The second one is related to, as I said, to the generational issue. We are really affecting the future of our children and grandchildren, who cannot say anything about this. So we are really legally, I think, and ethically liable towards the next generations. And I'm not sure that our legal systems are really equipped to deal with this type of problem. But the last question is a bit crude, but I'm really wondering if our generation is actually committing a crime against future humanity, because really, if we don't do something very soon, the future we may leave to the next generation can be a very dire future. So I think there are some big responsibilities. I think our legal systems, as far as I know, and of course somebody can correct me, are really not equipped to deal with these issues. So I think there is a big future for people who want to get into this type of business. And with this, Christina, I think I will stop my presentation. End my presentation.
Thank you very much, Filippo. Thank you for your thorough run through the climate science, but also for your thought-provoking question, especially to the spatial and temporal aspects of liability. And I do know that many lawyers work on these questions as we speak, but they are very, very, very pressing issues. Without further ado, let's move on to the second speaker on our panel. And I'd like to ask the speakers to please stay within 15 minutes of your presentation so that we have some time for questions and answers in the end. Our second speaker is Martin Siegert. He is the co-director of the Grantham Institute and likes snowy conditions, apparently. He works on climate change and environment at the Imperial College in London, and he will be talking about the integration of climate science in national and international climate policies. Martin, the floor is yours.
Thanks, Christina, and thanks very much, Filippo. A lot of the things I'm going to mention here are reinforcing some of the things you've just heard, but I'm going to add a few things as well and talk a little bit about the connections with policy toward the end. I did this talk for the Institute of Risk Management last week, and it took 10 minutes. So let's see if we can do it in that time. So this is me, and I'm in the middle of the edge of the West Antarctic ice sheet here. I'm a glaciologist. I study how the polar ice sheets are changing with climate change, how they have changed in the past. I'm at the edge of the Antarctic ice sheet around about there, but if you go to the center of East Antarctica, Vostok Station, the ice thickness is 3,741 meters thick. And you can core that ice, you can retrieve the ice from the surface down to the bottom of the ice sheet. The accumulation of ice in the middle of East Antarctica is only about 1.5 centimeters per year. So think how long it takes to build up over 3 kilometers of ice. It takes an awfully long time. Within that ice, if you retrieve the ice core, take it out and take a thin section, it'll have little air bubbles in it. And those air bubbles were once air in the atmosphere at the time when the ice was snow, when it was deposited on the surface. So as soon as that air turns into a little air bubble in the ice, it's now a time capsule. And you can core it, you can retrieve it, you can identify the chemical composition of that air, and you can reconstruct the atmospheric conditions, the atmospheric composition 500,000 years ago to today, and pretty much every year in between. And when we do that, what we see is we get this amazing curve over 500,000 years where the carbon dioxide level on the y-axis goes from 280 parts per million to around about 180 parts per million. This is an ice age. Come out to 280 parts per million and the world warms a little bit, 3 to 5 degrees centigrade, and interglacial between ice ages. Then you come down again. It takes about 90,000 to 100,000 years to get into a full glacial. It takes maybe 10,000 years to come out of it. So the warming is a lot quicker than the cooling is. It's called a sawtooth curve. This is the last ice age, 20,000 years ago, and the carbon dioxide level then was 180 parts per million. And at the start of the last interglacial, around about 280 parts per million, completely normal and as it should be. Then the Industrial Revolution happened and we started burning fossil fuels at an industrial scale, and the current level of carbon dioxide is closer to 415, 420 parts per million. So that's where we are today. And as Filippo said, that is unprecedented for the last 500,000 years or so. It's obvious what's causing this rapid increase since 1870 or so. This is the average temperature of the planet over the last 1,000 years. This is the atmospheric concentration of carbon dioxide overlain. And this is the amount of carbon dioxide that we're responsible for. And it's obvious that there's a linear relationship really between the temperatures, the carbon dioxide that we measure in the atmosphere, and our production of it. The Climate Change Committee, the UK's independent advisor to the government about climate change action, put out this curve just a couple of weeks ago, which showed that in its estimates that the average temperature of the planet is around about 1.2 degrees centigrade warmer than what it was pre-industrial time. So just adding to what Filippo had said. And again, this is a wonderful measurement of atmospheric concentration of carbon dioxide. A few things to point out about this. The steepness of the curve is increasing, so we're putting more and more carbon dioxide into the atmosphere. There is an annual cycle, and in the summertime when the vegetation grows, the carbon dioxide gets drawn down out of the atmosphere by a few points, but then it's put back into the atmosphere in the wintertime. And the difference between the two, the net difference, is the amount that it's going up each year. The other thing to mention is that I'm 53 years old, so I'm born around about 320 parts per million. And this is where we are, somewhere close actually to 420 parts per million. So we've put in 100 parts per million of CO2 into the atmosphere roughly in the last 50 years. As I said, it took the world 10,000 years to do that when it came out of the Ice Age. So this 100 ppm worth of carbon dioxide is 200 times greater rate of increase than it was when we came out of the Ice Age. And that's important to note. That's where we are now. Okay, so when was the last time we had 400 plus parts per million? You've got to go back about 3 to 5 million years ago in the Pliocene. Temperatures then were 3 to 5 degrees warmer than they are today. Sea level globally was something like 20 meters higher than it is. But of course, it doesn't stop there. We simply just extrapolate this curve toward 2100, just say, then looks like the level of carbon dioxide in the atmosphere could be somewhere between 800 to 1,000 parts per million of carbon dioxide. You've got to go back a long way into the past. The last time we had 800 to 1,000 parts per million. It's called the Paleocene-Eocene thermal maximum. 55 million years ago, temperatures on the planet then were 10 degrees centigrade warmer plus than they are today. Now, it was a time with a lot of volcanic activity at the Paleocene-Eocene thermal maximum, but it did take the world somewhere between 20 to 50,000 years to go from the low hundreds of carbon dioxide ppm to 1,000 ppm. We could do it in 80 years if we don't change our ways. And again, a couple hundred times quicker than the world did it naturally. Geologically speaking, this event in 55 million years ago was a spike. It really was. It's remarkable how rapid it was. It's not really a very good analogy to what we're doing. When I talk to geologists about, is there an analogy between 80 years worth of time and putting 1,000 parts per million of carbon dioxide in the atmosphere, what would be a good analogy for that? And they say it's an asteroid strike. That would be the analogy, not the Paleocene-Eocene thermal maximum. Antarctica today on the left-hand side is a wonderful, beautiful place. There was no ice on the planet at the Paleocene-Eocene thermal maximum, no ice at all. So I'm a glaciologist, and I want to study sea level and what it's doing. And let's go through some facts and figures before we start just talking about sea level rise, because let's put it into a context. How much ice is on the planet today in sea level equivalent terms? So you'll all have an idea in your mind, and you can think about it now. If all the ice melted all around the world, how much would the sea level go up? You get a value in your head. The answer is somewhere around about 66 meters. That's the potential sea level rise that exists on our planet right now. Now, there's 300,000 glaciers all around the world, apart from Greenland and Antarctica, just the small valley glaciers and ice caps. If they all melted, but Greenland and Antarctic ice sheets were left unchanged, the sea level would go up, but by how much? Have an idea in your mind about that? The answer to that is about 32 centimeters. By far the largest store of ice on our planet is held in the polar ice sheets. They are the greatest potential contributors to sea level that we have coming our way. Although it's fair to say that the half of the sea level rise that we've experienced to date is because the ocean has got warmer, and roughly the other half is because of the glaciers are melting. As we go forward in time, it's going to be the big polar ice sheets that do the damage. And how do we know that? Well, at the last ice age, just 20,000 years ago, water was taken from the ocean, evaporated, and it was put onto the land, deposited as snow and ice, and it just stayed there. So the ice sheets grew and the sea level went down. But how much lower was the sea level just 20,000 years ago? It's really not geological time. It's very soon. 20,000 years ago, it's not very far back in time at all. How much would the sea level lower? And the answer to that is about 130 meters. So in other words, I'm telling you that 100 parts per million of carbon dioxide, that's all, between 20,000 years ago and 10,000 years ago, caused the world to warm for somewhere between 3 and 5 degrees centigrade, and it caused the big ice sheets over North America, over Scandinavia, and many other parts of the world to melt, and the sea level naturally to go up at about 1.3 meters per century for 10,000 years, roughly. So, this is an existential threat. If all the ice goes, London is underwater. Now, it won't happen within the next century, and it won't happen maybe for some 100 years, but the potential is here. And of course, you don't need tens of meters to do lots of damage. We've got so much capital held up in cities around the world, and so hundreds of millions of people living their lives close to the coast, that only a meter or so of sea level is going to be hugely disruptive to the way that we live on our planet. And unfortunately, that's the way that we're heading. This is sea level over the last 140 years or so. And again, just like the temperature curve and just like the carbon dioxide curve, the sea level rise is going up, and it's going up at an increasing rate as well. There's a theme here, you know, not only are things going in the wrong direction, but the rate of change is also increasing. This is from the World Meteorological Organization for the last 30 or so years. And you can see again, the rate of sea level change, this is 10 centimeters worth of sea level change, is going up. And one of the reasons it's going up is because the polar ice sheets are starting to get mobilized now. We have enough time after we've been doing models of projections of what Antarctica and Greenland might look like into the future to now overlay our observations across those. And this was done in a paper last year where the 5th assessment report of the IPCC looked at how Antarctica and the Greenland ice sheets are going to respond to climate change in a worst case scenario, a best case scenario, and an intermediate scenario. And overlaying since then essentially are the data or the observations. As you can see, Antarctica and Greenland are tracking much closer to the worst case scenario than they are of any of the others. So we are really worried as glaciologists about the Antarctic ice sheets. This is a satellite image of ice surface height change, and it's a very accurate measurement, by the way, and it tells us that there are parts of West Antarctica where the ice sheet is losing mass at over 1 meter per year from the surface, and even in East Antarctica as well. Now, you might say, well, that's interesting. I'll be worried about that. But as glaciologists, we're really worried. If you take away the ice and look underneath the ice sheets, what you see is a bed, which is in blue, and that means the bed is beneath the level of the ocean. And so it's not the atmospheric temperatures that are doing the damage to Antarctica, it's the ocean warmth that's doing it. And the oceans can melt the glaciers and melt the ice sheets at 10 times the rate that atmospheric warmth can do. So we're really worried about the stability and vulnerability of the Antarctic ice sheets and its potential contribution of many tens of centimeters, upwards of meters, this century and beyond, especially. Now, I'm a glaciologist and I do this story about sea level, but I could equally do it about heat waves. And of course, just in the last week, we've seen heat waves in northwestern USA and southwestern Canada, reaching over 40 degrees centigrade. We've seen over 50 degrees centigrade in Death Valley. We've had 50 degrees centigrade in Pakistan as well. These are temperatures that are not livable, that you just can't live in those temperatures. And wildfires that's starting to accompany it. We did some work from the UK government a little while ago on if we can maintain temperatures to 2 degrees, this is like the Paris scenario, what damage do we avoid? And of course, the 2 degrees centigrade scenario is another 1 degree centigrade of warming that might be locked in, but we save ourselves an awful lot of pain if we do keep temperatures to this. What we've seen in North America in the last week will be nothing compared to what we might see if we don't reduce carbon dioxide emissions. Similarly for cropland decline, for water stress, and for flooding. This is Houston just in 2017 when Storm Harvey kicked in. And again, you know, flooding is more intense flooding is going to come our way, but we can reduce the severity of that if we reduce carbon emissions. So this is where we are. We're at 2021. These are the options that we've got. This is the choice we need to make to really push down carbon dioxide emissions. Globally, we need to do it nationally, but we need a global effort to make it work, because if we don't do that, there are many, many problems that are coming our way. Action now in 2020 will have an investment that's needed. It's not a cost, and it's an investment in our future. And we calculated in the Grantham Institute a few years ago that it's going to be something like 1.7% of global gross domestic product, possibly less than that for the United Kingdom itself, but globally around about that. If we delay by 10 years, it goes up by 0.5% of global gross domestic product. We can decarbonize starting from now at 4% a year, which is what Sweden did in the 1970s. But if we leave it another 10 years, we're way outside of our ability, a known ability to do that. And again, deploying various power options now is within scope. But if we leave it 10 years, we're going to have to deploy technologies at rates that we've never done before. So doing it now, putting policies in place now, is going to be cheaper for us, and it's going to be easier for us to meet the targets that we know, we absolutely know we must hit to avoid all the dangerous outcomes. Last slide, the Climate Change Committee did this analysis, and it was a superb analysis. This is the UK government's ambitions to reduce carbon dioxide down in the next 15 years, just till 2035, down to this level. And this is pretty much bumping along without any action at all. And what they did, they color-coded the government ambition, the UK government's ambition on this. Green, fully on track. Yellow, potentially on track. Orange, some action, but risk of falling behind. And red is falling behind. You can see more than half of the ambition is arguably just not really there. When you look at policies, it's even worse. These are the policies needed to drag down. We've got a little bit of green stuff over here, a little slither of yellow, and then the bulk of it is either action, but a real risk of falling behind, and the red actually is not there at all. We have government statements, we have government aims and ambitions, but in the United Kingdom, and it's possibly one of the better governments on this measure, we do not have the policies in place. And I suspect that is true globally. We have a lot of statements, a lot of ambitions, but we're not yet in a position where we can comfortably say we've got policies in place that's going to drive the changes that we absolutely know we need to do. And I'm going to stop at that point. Thank you.
Thank you very much, Martin. Thank you for, again, your scientific input, but also the link back to policies, especially the UK policy that you showed us in the end. I think that connection is really crucial also, not just for scientists and policymakers, but then also eventually for litigants and judges if these questions come up before courts. I would like to invite our third speaker on the panel, that is Professor Myles Allen from the Oxford University in the United Kingdom, and he is Professor of Geosystem Science and will be talking about attribution of climate change related harm to individual states or private companies. And in the context of climate litigation, I think this is one of the most crucial aspects to shed light on when it comes to the question of causation between a particular act and the climate harm to happen. We haven't really seen many of these cases yet, partly to the missing attribution possibilities, but the field of science is apparently growing, and we're very much looking forward to your talk, Professor Myles Allen. The floor is yours, please.
Thanks very much, Christina. Can I just check if I managed to share my screen successfully?
We hear you and we can see your slides. Yes.
Excellent. Okay, so thanks very much for the opportunity to talk to you. And I'm going to talk about this challenge of attribution. It is reaching the courts, and just to reiterate, the reason is very simple. That the evidence for global warming is completely clear. Just to reinforce what Martin and Filippo already told you, global warming has actually reached 1.2 degrees now with the updates to the data sets. And that is predominantly, so orange line here is the human contribution, blue line is contribution from natural factors. You can see that natural factors like the sun and volcanoes have had some influence, but it's primarily human-induced warming that we're seeing here. And that is primarily due to cumulative carbon dioxide emissions. So the dark gray wedge you see in this diagram shows the contribution to the increase in temperatures that comes from carbon dioxide. So other factors do contribute to the warming. Other human-induced factors do contribute to the warming. We understand what they are, but it's 80% due to carbon dioxide. And that's really important from the perspective of attribution, because we know where this carbon dioxide has come from, and we understand how it affects global temperature. So if the lawyers want a very simple equation to take home with them, 1 ton of carbon dioxide into the atmosphere drives up global temperatures by just under 0.5 trillionth of a degree centigrade. So although that doesn't sound very much, we are pumping carbon dioxide into the atmosphere at a rate of 40 billion tons per year. And so you can do the sum in your heads. That's 0.18 degrees per decade. And that is 80% of the observed warming. So it's pretty simple, really, what's going on. And that's, of course, important for the legal profession, because you don't want this to be complicated. I mean, scientists might like it to be complicated, but it's not. It's actually really simple. every ton of carbon dioxide drives global temperatures up by the same amount as the last, which of course means that carbon dioxide released into the atmosphere by Standard Oil back in the 19th century is having exactly the same impact on global temperature as carbon dioxide released into the atmosphere by products sold by Gazprom last year. So, you know, that simplifies the attribution problem and allows us to do exercises like this from Brenda Ekversel's paper in 2017, tracing the warming over the 1880 to 2010 period to emissions associated with products sold by major corporations. This is possible because that link between carbon dioxide and global temperature is so simple. So if that was it, there wouldn't be very much for me to talk to you about. You just have to go away and find out who's been emitting what, and you know that's not certain, of course, and there's work to be done tracking down these emissions, but there's not so much science in it. It's mostly an accounting problem, if you like. But the interesting part comes from the fact that most climate-related harm is not associated with the increase in global average temperature, but with extreme weather events. In fact, it's particularly associated with hard to forecast weather events for, I guess, obvious reasons. If a weather event is completely, or a development in the weather is completely predictable, people can adapt to it. They can avoid it. They can anticipate it. But it's the hard to forecast events that are particularly harmful. And of these events, relatively few of them we would argue, never have occurred but for climate change. So it used to be the case that there was a test in courts, the but-for test, you know, but for the actions of the defendant, would this harm have occurred? Well, it's very difficult with harm that relates to weather to ever say, no, this weather event couldn't have ever happened without climate change. Some people are arguing we've almost reached that threshold for the most extreme heat waves, but in fact, I think even there, the jury is still out, because the problem is when you get to a weather event that we can't simulate in a pre-industrial climate, that we say the models just don't do this kind of heat wave if we don't have human influence included in the models. You very often find the models don't do the heat wave either, even when you do include human influence. So then it's quite difficult to quantify the change in risk. You know, you're dividing 0 by 0, so that makes a challenging a sort of scientific challenge. We're in much better shape when we're talking about events that, you know, do happen. They probably happen rather seldom, which is why they cause so much harm when they do happen, but where the influence of climate change is, as it were, loading the weather dice towards more such events happening and away from other kinds of events happening. So here you have a sample of weather dice, and you should be able to look at those to realize, if you sort of stare at them long enough, you'll realize there's suspiciously large numbers of 60s in this weather dice. So if you saw a dice doing that, you'd know it was loaded, and you'd be able to quantify the loading. And we do this kind of thing, understanding the human influence on extreme weather by looking at an event which occurs in some climate variable. So you've got some climate variable which has exceeded a threshold, which has caused some harm. That's the vertical dotted line here is the threshold of harm that has occurred. And in the distribution of weather that we expect in a world without human influence, the so-called counterfactual world, there is some probability of that threshold being exceeded, P0, in this diagram. But as we included human influence, we increased that probability. We loaded the weather dice in favor of a particular event occurring, and we can quantify this. We can ask, how has climate change affected the risk of a particular harmful weather event? Let me give you a practical example of this. Imagine we have a four-sided weather dice. It's probably quite difficult to visualize, but never mind, bear with me. These four sides of the dice correspond to different types of North Atlantic winters. We have a chilly winter with a northerly flow over the North Atlantic. We have a soggy winter, westerly flow coming into Western Europe. A cold, very cold winter, where we have easterly flow coming out of Siberia. And finally, we have a sunny winter where we have a southerly flow from Africa and the Mediterranean. So it's not predictable in any particular winter which one of these which one of these sides of the dice will emerge. But what we can do using simulations in computer simulations in silico experiments, we can roll the weather dice multiple times and look to see to what extent particular events that have been observed in reality are becoming more or less likely due to external drivers of climate change. So this is an example of an experiment we did a few years ago, looking at a very wet January that occurred in the UK, caused widespread flooding and quite considerable damage. And we simulated this event literally hundreds of thousands of times using a weather model, and showed that under the actual conditions that applied in 2014, that's the red line here, the probability of rainfall exceeding a particular threshold depends of course on the height of the threshold. Higher thresholds have a lower probability of being exceeded. That's why the red line slopes up to the right. Okay, so these dots here tell you what's the size of an event you'd expect to see every 100 years or so, or every 50 years, or every 200 years. That's what the red line means here. It's called a return period diagram. And then we redid the experiments with removing various estimates of the signal of human influence on climate. And those are the blue lines here. And you can see they're all to the right of the red line, or they're all below the red line, which means that where the threshold, for any particular threshold, that was the threshold which was actually exceeded in 2014, the dashed line you're seeing there. The probability of it occurring in the world as it was might have been 1 in 100, but the probability of it occurring in the world as it would have been if we hadn't messed around with the climate, a 1 in 100 year event would have been rather lower, and the probability of a event of the magnitude we observed would have been much lower, more like 40% lower, in fact, was our estimate in this study. So that's what we're able to say, is that because there's been a general shift of these lines to the left, the probability of an event of a particular magnitude has increased. This isn't the only way to approach the challenge of relating external drivers of climate to individual weather events. A complementary approach, much well developed by Ted Shepard at the University of Reading, is called the so-called storyline approach, where instead of asking how the probability of events have changed, we can ask, well, given the event has happened, and this example I'm showing you here is Superstorm Sandy, and experiments that were done shortly afterwards, looking at the impact of higher sea surface temperatures on the strength of Superstorm Sandy. And you'll see on the left, with higher sea surface temperatures, the depth of the low pressure in the center of Superstorm Sandy was lower than it was without those high sea surface temperatures. So we are seeing here the mechanism of higher sea surface temperatures is strengthening the superstorm and contributing to the enormous damage that it caused. So these are two complementary approaches to understanding the link between external drivers and extreme weather. And just to warn the lawyers present, you're going to have to get your minds around both of them, because they're both relevant to the question of harm in any individual case. Just to help you with sort of understanding these things, let's think back to a much simpler system, but an interesting chaotic system introduced by Ed Lorentz as an analogy to the chaos in atmospheric weather. And this is the famous Lorentz butterfly. You've probably seen the sort of thing swirling around in a, it's an analogy of the way the atmosphere behaves chaotically. And the dots here show where we see the atmosphere in any given hour in a simulation of the Lorentz butterfly. And the curve at the bottom shows the distribution of one of the coordinates of the Lorentz system. And if we blow on the butterfly, so to speak, impose an external forcing, this was an idea suggested originally by Tim Palmer, you see there's a shift in where it sits. And in fact, it shifts to the left, somewhat surprisingly in this particular case, even though the wind on the butterfly is blowing it more to the right, the effect of the wind is to shift the density of points to the left. And what that means is, in this particular case, the impact of that external forcing, which you might think is analogous to increasing greenhouse gases, for example, is to reduce the probability of threshold exceedance events. So this is what you would get from a risk-based approach, thinking about attribution in this very simple system. So we've now got twice as many events here before climate change than after climate change. But if we zoom in on these individual events, then you see that actually the impact of the external forcing looks very different. So the red events here are the events that occur with the forcing, and then the green events here are what happens if we take the forcing away. And you'll notice they're shifted slightly to the left. So in this case, if you sort of take a storyline approach to understanding these events, you'd see the external forcing is increasing the magnitude of these individual events. So here's a situation where the probability of the events has gone down, but the magnitude of the individual events, assuming they happen anyway, has gone up because of the same external forcing. I can't make it any simpler than that because that's just the way it is. We're dealing with a chaotic nonlinear system in the weather, and we have to deal with both of these things contributing to the way external drivers affects individual events. So the risk-based and storyline approaches need not always agree, although they do normally agree, in fact, in most of the cases we've seen so far. And just to bring you bang up to date, this is some work we've been doing here in Oxford, paper just submitted, and I'm really excited about this development because I think it's where this sort of attribution work will have to go. This is a study which Nick Leach, a colleague here in Oxford, has led, where we actually used the full weather forecasting model at the European Centre for Medium Range Weather Forecasting and repeated, this was looking at a heat wave which happened a couple of years ago, and looked at the impact of varying carbon dioxide in the actual forecast model that was used to forecast the heat wave. And this approach allows us to reconcile these forecasts, these risk-based and storyline approaches to attribution. The only problem with this approach, by the way, is that it's expensive. You have to rerun a full-scale weather model. But to remind you, I think Filippo already showed you this slide, the numbers are potentially large. So if I just wrap up, sorry, I've gone slightly over time with some take-home messages. Most of the unavoidable harm due to climate change is associated with hard-to-forecast events. There's a reason for that. It's the hard-to-forecast events that hurt people because they're not ready for them. There are important exceptions, including glacier melt and sea level rise. So we need to understand how external drivers affect both the probability and the magnitude of chaotic events or events in a chaotic system. And we can draw our strongest conclusions when both the risk-based and the storyline approaches align. And, you know, it is possible, if I make an appeal to the lawyers here, it's possible to use state-of-the-art weather models to actually conduct this kind of attribution research. But the problem is cost. It costs as much as forecasting the weather in the first place, but the cost is trivial compared to the cost of impacts or potential liability. So, you know, in my view, this should be part of an essential climate service. So, but it's going to be up to you, the users of this service, to, you know, phone your Met service and say, why aren't you doing attribution if they're ever going to actually put the investment required to make this happen? Thank you.
Thank you very much, Myles, for your presentation. It gives us half an hour time for questions and answers, and I see that some of you have already answered some of the questions in the chat, which is good. But there's still a couple of questions remaining, and I would like to start with the one that just disappeared. I'm sorry, I have to find it. Okay, I would like to start with a question that referred back to the Paris Agreement, because most of you, I think all of you, refer to the Paris Agreement, and scientists generally do, in terms of calling it the instrument that sets the danger threshold or the Paris Agreement scenario. But in all these references, you mentioned 2 degrees centigrade. Now, the Paris Agreement doesn't set a threshold of 2 degrees. It was an option that was negotiated, but negotiators and parties in the end decided to set the threshold at well below 2 degrees. That was another option, which was consciously decided. And the reason for that was to create a buffer to 2 degrees. So that well below 2 degrees means well below and not at 2 degrees. So my question, and I think that is also a question that Cordelia Bear put here in the chat, is why do scientists refer to a 2 degree threshold and not to well below 2 degrees? Including that safety buffer that is built into the Paris Agreement. And how about 1.5 degrees? Paris Agreement sets 2 goals. We usually see the 2 degrees reference as the Paris threshold. So how does that relate to that threshold that you refer to? And I think the question is primarily to Filippo, but also to Martin.
Okay, let me say that I'm not an expert on why the 2 degree was chosen. I mean, the 2 degree global warming threshold is a threshold that has been around for a long time, actually much before the Paris Agreement, and it's a threshold that I think, and Myles maybe can correct me, or Martin can correct me, it's a threshold that the European Union had set way before the Paris Agreement. It's sort of recognized, I would say, broadly speaking, as a threshold of, below which the impacts of climate change are still somewhat manageable. As far as I know, during the Paris Agreement negotiations, then there were these other thresholds coming up, the 1.5 or the well below 2 degrees doesn't mean, in my opinion, pretty much. Yes, okay, what is well below? 0.1, 0.2, 0.3, nobody really knows. But the other threshold is that has been talked about is 1.5. So one could say 1.5 to 2 degree is a threshold. And this came up during the Paris negotiations, as a result of this. So we went from 2 to less than 2. Okay. I personally think that 2 degrees is probably one of the most optimistic thresholds that we can actually have as a target. That's why I personally mention in general 2 degrees. I think the others are, given how things are going, are highly unlikely thresholds. The other thing that I want to say, I think was mentioned by somebody before, is that the Paris Agreement is not really a binding agreement. As we all well know, it's based on voluntary contributions. It's not legally binding, and the voluntary contributions, anyways, lead to much more than 2 degrees. So in some ways, I use 2 degrees because, in my opinion, this is the lowest achievable target. But probably, yeah, you're right. We should say maybe 1.5 to 2 degrees. But quite honestly, I don't think we'd be able to stay within 1.5 means 0.3. I mean, if you remember what Myles said, we are at 1.2 warming, 1.2 degrees. This means that staying within 1.5 degrees, 0.3 degrees, right, Myles? So how many gigatons of carbon are 0.3?
Yeah, I mean,
little equation. So
to put it into perspective, that's the amount of warming we've already seen since the 1980s. So it means limiting future warming to, or since the 1990s even. So it means limiting future warming to only the warming that we've seen in the past few decades. So I mean, clearly that would be great if it could be done, but it does mean effectively stopping the warming within the next 20 to 30 years, which would be challenging. Possible, but not, I think, and that's an important point to make. I mean, I think one of the concerns people have about some of the sort of, when we were working on the 1.5 degrees report, a lot of countries were clearly quite sensitive to the possible conclusion that the Paris Agreement that the 1.5 degrees goal in the Paris Agreement didn't make sense because it was already impossible at the time they signed it. And I think it's very important to stress, no, it wasn't impossible. It was just extremely challenging. It may be becoming impossible because we're continuing to dither and emissions are continuing to go up. But at the time the Paris Agreement was signed, we could have still limited warming to 1.5 degrees. You're putting on a skeptical face there, Filippo. I mean, it was geophysically possible. Whether it was politically possible, I don't know. This is a different question.
No, it's not a skeptical face. I kind of think it's extremely challenging.
No, I think but the challenges are political and economic. I mean, it's geophysically possible.
Yeah, and I actually don't know whether there were some specific issues that pointed to 1.5 versus 2 or something. But I remember that, and you might correct me on this, that the 2-degree global warming threshold has been going on for much earlier than
yeah.
I think it was the low line
in Europe,
Pacific nations that really pushed the 1.5 scenario in Paris, and John Kerry was very much behind it. Can we work harder? Can we work harder than 2 degrees? Can we actually get it down to 1.5? And there was sort of a coalition that was established to do that, and what was reflected in the Paris Agreement really stemmed from those early discussions, and it took a lot of scientists on the hop, because all the models and all the projections and things were really talking about 2 degrees, and then Myles and lots of others started having to sort of redo it all and think about what 1.5 actually means, and that actually was a really good outcome of the Paris Climate Summit, that they provoked us to work harder on this. 1.5 is like, that would be fantastic, but that's the minimum that we're locked into. When you look at all the pledges that were made in Paris and assume that they're going to be realized, we'll end up with 3 degrees of warming by 2100. So we're a long way from rhetoric and ambition to actually policy and implementation. And that's, for me, that's a real concern.
Absolutely. Well, thank you so much. I had the privilege of negotiating that particular part of the Paris Agreement, and you're absolutely right. There were political concerns, especially by small island developing states, to even well below 2 degrees, and they needed to see 1.5 degrees, saying at 2 degrees we are gone. Our islands may not be there anymore. But again, the Paris Agreement talks about well below 2 degrees and does not set a threshold at 2 degrees. So I was just reacting to the reference to the Paris Agreement goal scenario in RCP 2.6 that talks about 2 degrees, which was a very conscious choice not to have, but well below. But anyways, let's move on. There are further questions here in the chat. They come and go. Every time I open the chat, there's some questions gone. But there was one question regarding the different contributions by different greenhouse gases. And Filippo, you talked about methane. Lindsay asked about the contribution of agriculture to methane emissions that you mentioned. And then she wonders, what about the role of melting permafrost, thawing permafrost with methane releases? Is that taken into account? I understand that's one of the tipping points, but you didn't venture into that. So that's her question.
I think that the two main contributions are, of course, at least current contributions, are fossil fuels, I think about 60%. And methane is the second largest. In terms of the melting permafrost, I think it's pretty low for now. Maybe Martin can comment on this. It's still not sort of a dominant contribution. As far as I know, it's mostly related to intensive farming, especially cattle, sort of, as you know, methane is emitted by cattle. So I think a permafrost is more, it's more of a concern for the future than for the present. But maybe Martin can comment on this.
I agree, Filippo, but it's a real concern for the future. When you think about the warming that we had in Siberia Arctic last in the winter, you know, it was, and in the summer as well, you know, it's 38 degrees centigrade that it got there. And the thawing out of Arctic permafrost is a real problem. We haven't seen the great influence of that methane yet, but that's not to say that it's not going to happen into the future with further thawing. And it's, you know, you can argue it's pretty likely. So I think that's something we just need to know.
Yeah, I think we may want to mention that when the future projections are made with models that include the carbon cycle, so that include also the permafrost melting, these tend to give a much higher warming. So the expectation is that the whole issue of the carbon cycle, including the permafrost melting, is quite an important one, although still quite an uncertain one. You know, the spread among the models tend to be much larger with than without the carbon cycle.
Thank you. Let's stay a little bit more in the science realm, and then we move to the connection to the legal world, if I can say so. There's a question from Alison Baker, and she asked about denial of climate change and climate science. She's asked, how do climate change litigants and scientists, and in this case, deal with scientific papers denying the existence of anthropogenic climate change?
Maybe Myles wants to.
Yeah, I can talk to that. I mean, one thing which I've been quite interested in this field, I mean, ever since I wrote that paper back in 2003 on climate change liability, the courts don't seem to be that interested in the sort of extreme denial position. I think it's because courts sort of operate on a balance of evidence principle, and they kind of recognize, you know, they recognize that the sort of blanket denial, the sort of religious denial almost position isn't really tenable, and so that my impression is it's not really. I mean, you know, for example, just to give you, I was involved in a case, unsuccessful case, as was between the cities of Oakland and San Francisco against Chevron and others a couple of years ago. And it was interesting in that case, neither the defendants nor the courts, and certainly not the plaintiffs, of course, were interested in talking about, in questioning the IPCC science. The defendants, the big oil companies, they all said, yeah, we totally accept the IPCC science. They weren't interested in the sort of climate denial line. They were provided with lots of amicus curiae briefs from various, you know, the usual suspects writing in, trying to be helpful. And interestingly, the defendants just completely ignored these climate skeptics because they just realized it wasn't tenable. So that seems to be the way it's going. Interested in other people's perspectives on this, and perhaps the lawyers on the call thoughts as well.
No, if I may add just a quick comment, I don't think I've seen a lot of papers in the scientific literature that you could define as denial papers. To be honest, in fact, I would not be able to quote even one. Maybe I'm not reading the literature. They would have such papers, but I would say. And again, Myles or Martin or Roberto can call me on this. I would say that now the so-called deniers are it's really minuscule voice. And
I think there's something that's actually more sinister at play here, because climate denial is kind of lunacy, really, and it's so easy to sort of argue against it because it just doesn't hold any intellectual water. But there's a rise of something called the lukewarmers. And these are people that sound reasonable, right? They say one of three things. They say climate change is happening, we're responsible, but it's not as bad as you're being told. Or they say, yes, it's happening, but we simply can't afford, you know, all the changes that are needed, we can't afford it. Or they say 3% of GDP globally is more than enough to cover the damages. Now, they're inconsistent messages, but they're all coming from the same cohort of people sometimes. And it's a dangerous message, because think about it when you have an illness and you go to a doctor and the doctor gives you bad news And he says, oh, you might want to get a second opinion on that. So you go to another doctor who says, oh, well, yeah, it's, I see what they're saying, but it's probably not as bad as the first doctor was telling you. Our human condition tells us that's the one, that's the opinion that we will sort of tend toward agreeing with. And that's the problem with lukewarmers. For those who don't understand about the climate problem, they will tend to warm to that idea because, oh, it sounds reasonable. Climate change is happening, we're responsible, but it's just not as bad as the scientists are saying. So that's why it's a real problem for us. You know, we're actually running a campaign at the moment at the Grantham Institute to try to tackle the rise of lukewarmism, because it's something we should all take some notice of.
And one thing which that particular group is very fond of, so apologies if my talk was a bit technical, but I'm afraid you just have to get your mind around that, because they love banging away at the fact that, oh, this is just weather, it's not climate. You know, oh, we can only say things about global temperature. No, we can say a lot more than global temperature. But one thing I think which, you know, we should all be campaigning for, and I know, sorry, Roberto, because you know that I say this whenever I get a microphone, you know, saying what we are doing to our weather should be part of the job of your weather service. And it's, you know, your weather service in whatever country you're in could, at the end of every season, tell you, for all the harmful weather events that happened in that season, they could tell you how much human influence on climate contributed to those individual harmful weather events. The only reason they don't do this is because they don't have the money to do it. But it's just a matter of rerunning their model. You know, it's just computing time. And you compare what that would cost to the sort of numbers we're talking about in terms of liability, in terms of impacts, in terms of just understanding the benefits of understanding what's going on, it's trivial. And why we don't have a much greater demand from all sorts of interest groups, why aren't we just being given this information regularly, you know, not by random academics, but by the weather services? It should be it should be an absolutely standard part of climate services. And we're getting there, but it's sort of, you know, 2 steps forward, 1 step back, it seems, a lot of the time. I hope Antonio Navarro is listening.
We have quite a large audience. And a follow-up question on this issue of climate misinformation or denialism. The average public seems not yet to be entirely convinced, you know, that we have to change, and that we have to change drastically and rapidly. And one of the reasons may also be the misinformation, not just in scientific journals, if there is any, but more in, you know, social media, fake news, other fora where information just passes through unchallenged and is, you know, easily and freely accessible to anyone and everyone out there with any particular filter for its scientific merit. And the question here to you is whether that would legitimize to curtail the freedom of expression to a certain extent in order not to misinform the public in general.
I don't think I understood exactly the question. Can you repeat the question? I don't think I understood it exactly.
Does the misinformation that is happening through various information channels currently legitimize a curtailing of the freedom of expression?
Oh, well, I don't know. I'd rather not answer.
I think idiots are allowed to be idiots, right, in a free world, and they can do that, right? And it's up to us individually to come to a conclusion on what we think the world that we want to live in is going to look like, and what we want for our children and who come after them. The science is really completely clear about it. You know, the scientists have done an amazing job over 30 plus years to get to this level where we understand the problem. The next step, we're going to need more climate science, don't get me wrong, but the next step is to translate that knowledge into areas of society that aren't necessarily particularly scientific, and that is into policy, and it's potentially into law, it's into behavioral change and things like that. And that's our challenge. How do we translate that knowledge, that deep understanding of the problem that scientists have? How do we translate that to other sectors that absolutely need to adopt the conclusions and do something with it. And that's the big challenge that we all have in the world at the moment. But I would never stop an idiot from being an idiot, so long as we understand that they are.
Yeah, no, clearly media law is well outside my expertise, but I personally agree with Martin on that one. But I would just pick up on one angle on this. I think part of the reason for public disengagement is not disbelief that something is happening, but a feeling of inevitability that there's nothing anybody can do about it. I mean, and this is why there's been a couple of questions on negative emissions in the chat, I think it's very important that we don't regard these sort of highly engineered solutions to climate change as sort of, oh, we can carry on because then we'll just fix it later type of get out of jail free card, so to speak. On the other hand, the existence of an alternative to dumping carbon dioxide into the atmosphere is really important. And for example, on that, to come back to that San Francisco case, sorry, I haven't been involved in very many cases, so that's my example of one. But one argument we had among the lawyers acting for the plaintiff, well, I was advising them, but it was very interesting to me to see in the papers they assembled for that case that actually Exxon Mobil was actually talking extensively internally about carbon capture and storage, about essentially the alternate technologies for disposing of carbon dioxide back in the 1980s. And then they didn't do it. And I was very interested in this. I'd not seen these papers before that case, and the lawyers were sort of drawing my attention to them. And I thought it was really important to draw attention to this because it showed that, you know, for a very long time, companies have been well aware that there is an alternative to just dumping carbon dioxide into the atmosphere. And I still think that's the case. I mean, as it happened, that wasn't the way that they decided to argue that case. But I do think it's really important. I think it's very important for the public to understand that there is another way. It's not as if this is just embedded in the way we live. In fact, when I point out to a public audience that for 50 pence on the cost of a litre of petrol, the company selling you the fuel could dispose of the carbon dioxide. I mean, that's what it would cost to capture that carbon dioxide back out of the atmosphere and re-inject it back underground. People are sometimes rather outraged. It's like 50 pence on the, I mean, that's quite a lot. That's, you know, that's 50% more than we spend on petrol in the UK. But they say, really? You know, it can be solved for that much. And okay, you need to be careful. It can't be completely solved for that much. But the point is, the solutions are out there. And when you break it down to, you know, what the incremental cost would be on all of the activities that we use fossil fuels for most of them, it's tiny, it's invisible, the cost of sorting out the problem. And that's where I think, you know, that we need to do a better job of communicating to the public is that this is not inevitable. There are alternatives. And then I think you're on a much stronger argument footing.
If I may add something about communication, I actually think that there is a problem of communication because, I mean, if you just think of this Fridays for Future phenomenon, okay, I don't know how it was in other countries, but in Italy, this was something really amazing to me, okay? And these kids actually don't say anything that we haven't said for 30 years. In fact, they say, listen to the scientists. And yet they've been able in 1 year, in 2 years, to reach a segment of the population that we totally missed, I would say. So there's something clearly that we are not doing correctly when we are actually communicating this problem. I think maybe we have to go through other channels. Maybe we have to go through influencers. I don't know, to famous people, you know, embracing this, you know, like DiCaprio or whatever. But obviously, in terms of communication, we are doing something not correct, or we have been doing, because there are problems. Another two issues I wanted to one is I fully agree with with Myles when, sometimes people think that to achieve the Paris target or whatever, it takes revolutionizing our life and something that's impossible. It's actually not true. I always give the examples that all we need is to waste less energy, waste less food, less water, and be just more rational about the way we use the resources of the planet. And this will not make our life worse, will make everybody's life better. I always try to give this message. So it's perfectly doable, but somehow there is this feeling that, oh no, this is too much. Our life will change too much. We'll go back to the ice, to the rock age or whatever. This is totally false. And the third thing, which is I think specific, especially to Italy, I don't know how it is in other countries, the climate change often becomes a political issue, in the sense that the right wing has a certain opinion, the left wing has a certain opinion. So if you express an opinion, you are given a political stamp. And of course, this makes people very skeptical about what you're saying, because they start thinking you're not objective anymore. In Italy, this happens a lot. When the government changes, you will start seeing different people going on TV or going on the media or whatever. I don't know how it is in England or in Germany or whatever, maybe a bit less so. But I think this is very dangerous for the debate, because it's not based anymore on objective facts, but it's based on political issues. And this makes everything arguable.
Thank you. Let us focus a little bit on what needs to be done. There's a question in the chat about translating science into rights and obligations. Now, you talked a lot about climate scenarios and possible effects of different degrees of warming. Now, most of the climate litigation cases that are currently ongoing are focusing still on preventing that, and are trying to increase the mitigation ambition of either states or companies. And one of the central questions usually is how much needs to be done in order to prevent global warming from reaching the thresholds in the Paris Agreement of saying well below 2 degrees or even at 1.5 degrees. Now, none of you really addressed this issue. What exactly needs to be done, and what could courts or judges tell individual companies or states of what they need to do in order to not exceed the Paris temperature goals?
Well, maybe I will start. Of course, I'm not an expert on this, and this is why I haven't really replied to this issue anymore. I think the message we can give is the message of the urgency. What needs to be done is clear. Decarbonization of the energy system. This is the main thing. This means phasing out fossil fuels, going to renewables or whatever. And we know that the technologies are more or less there. And we also know that some countries, some areas are, I would say, going in that direction. Europe, for example, I would say also the United States, there are some good indications. The big issue is the emerging countries. China, India, Africa will start very soon, and so on. So I think it's very important that the development of these countries, and they have the right to develop like we did, will happen not the way we did it, but using the so-called green economy. So the tools are there. It's a matter of implementing them, and for these emerging countries to do it in a way that is feasible, that will not cost them too much. I believe a lot of the negotiations are on this specific point on how to transfer technologies to, I think emerging countries is a better word than developing countries, so that they don't do it through a fossil economy, but through a green economy.
I can say a little bit. So, the UK has a legally binding cross-party climate change act. Don't really understand what the legally binding bit truly means. But what I like about it is that the Climate Change Committee is independent of government and it sets the carbon budget, which the government then has to meet, and it's legally bound to meet those carbon budgets, and currently not yet doing that, and we'll probably find out in coming years what legally binding actually does mean. But it is cross-party, and so when another government comes in, the carbon budget doesn't change, and so it's good from that perspective, and there is cross-party agreement that it's the right thing to do. You can argue about policies and things a bit later, but I always think there's only so much a government can do. There's a lot of attention on governments, and I feel quite sorry for politicians because it's a difficult job for them. They're being asked to invest in things now that will have benefits way outside of their own political lives. It's the right thing to do, of course, but from a political cycle perspective, it doesn't really work very well. But what I like to think about also are the non-state actors and their responsibilities in this: the cities, the industry, corporations, smaller states. They have a lot of influence, they have a lot of ability, and actually a lot of the changes that we're seeing, a lot of the most rapid changes that we're seeing have happened as a consequence of that interplay between companies, local people, local organizations, and states. And that, I think, can make a difference. Who would have thought, 15 years ago, that the cost of renewable energy would have shot down in the way it did? It wasn't a government that decided to do that. It was this interplay of technology, of having an opportunity, of realizing the investments to make it happen. And actually that sort of thing introduces a whole new area of thinking. It's about business, it's about business opportunities, it's about driving this transition in the way that business drove the Industrial Revolution. We need the same approach to drive the zero carbon transition as well. And if we don't get business properly, completely on board with this as an opportunity for it, right, I fear we won't make the targets that we're setting ourselves. So if business is the thing, if we absolutely think business is going to do it, are we doing a very good job in mobilizing business interest? And at the moment, I don't think we are. I think that's something we've got a long way to go. And from a university perspective, I would say that we are not doing a very good job in universities. Myles knows this, that our business schools around the world are not facing this problem. I was talking to our MBA, we do a program in the business school at Imperial College, very nice, a climate program, but our MBA program doesn't have it. And I was speaking to the MBA students just yesterday in a program, and I was staggered by their lack of knowledge of this problem. And I suspect the same is true, multiplied thousands of times around the world. We've got to get the next generation fully equipped to tackle this, and business is integral to the solutions.
Can I chip in on this? Thanks, Christina. Sorry to, I absolutely agree with Martin. We've got to get some business on board on this one. And this is actually something that I think the legal community can really play a big role in, because, I mean, the old cliche is that the market is driven by fear and greed. At the moment, there's no downside really for a business to doing nothing about climate change. So a few businesses are stepping up because they've got forward-thinking CEOs with maybe kids who are sort of asking them tough questions, and that's great. But their competitors can do well out of that situation. And they're holding back the more the competitors. There's no penalty to ignoring the problem in effect at the moment. So that's where I think a little bit of cold wind on the necks of businesses that are setting out to ignore the problem, coming from the legal community, raising cases like the liability cases that have been brought. It introduces an element of risk to ignoring the problem, which I think is needed, because we cannot expect businesses to spend serious money just out of the goodness of their hearts and their thinking about the next generation. They must be able to make a case to their shareholders. Look, if we don't do this, we are at risk of litigation, and so there has to be a real risk of litigation against businesses that are trying to ignore the problem or ignoring obvious solutions. And that's where the legal community has a very important role to play. And the litigation doesn't even have to succeed. It just has to be there as a risk for businesses. A lot of businesses are looking for reasons to move, looking for reasons to convince their shareholders, but they need to be able to point to that risk as a motivator.
Absolutely. Thank you so much. I see that the discussion could go on perhaps for an hour. It's really only the start of it, and it's a very important interface between the scientists and the legal community. I think this is something that should be happening much more often and also deeply. I think these discussions and these exchanges are extremely important, and much can be learned, I guess, on both sides. And I just agree with you, Myles, what you said in the end. We've seen a lot of litigation that is strategic, that is supposed to give that signal that whatever you do now by continuing business as usual puts you in the risk of being litigated against. And that recent case in the Netherlands against Shell and the entire Royal Dutch Shell group is telling. We still have to see how it goes through the court system in the Netherlands, but the courts of first instance said that Shell was to increase its ambition to 45% of emission reductions compared to its 2019 level. But this is an example of where the science is really important, because how can a court tell a company exactly what the emission reduction target should be, when, and based on what kind of scientific grounds? I think here the interface is just coming to the forefront and needs to be explored much more deeper. I get the ping here from the organizers that we do have to stop, but I do want to thank you, all three of you, very, very much for taking your time, for sharing with the audience your breadth and depth of knowledge, and making it so clear and digestible for the legal audience here in the digital room. Thank you so much, and thanks very much to the audience for putting up a lot of questions. I see many have been answered. We tried to answer some in the panel here, but some have to remain open. Maybe, you know, if some of the panelists can copy them and address them later, might be very helpful. Thanks very much to the organizers as well. And with that, I put the floor back to Roberto, I guess.
Yes, thank you very much, Christina. Thank you for an excellent sharing of this very interesting section. Myles, Martin and Filippo, all the friends and colleagues, thank you very much for joining us. It has been great to hear you talking about science aspects to the legal experts. The next section, which will start in half an hour, will actually see an expert in hydrology and risk management to chair a group of experts in legal aspects to talk about perspectives from law, cross-cutting issues. So for the people who are still with us, you don't need to disconnect, you can stay connected. We will resume at 1700 Italian time, which is 1400 in the UK. So thank you again to everyone for your role and contribution. We break for 27 minutes. See you in 27 minutes. Thank you very much. Bye.